Tell me when to go, Josh.
Yeah, give me just 2 seconds. So I'm going to put this on Twitter. Everyone can share it. And I think you have the green light.
Nice. Yeah, hello everyone. I'm Chris from DeSci Labs. Great pleasure to be here. Thank you to Jelani and Josh for bringing such a great group of enthusiasts. It's a great pleasure to see people like you coming into the space and with their curiosity and their skills to help us build the future of science. So science is broken, as you might all know or intuit. But the question is, what is broken in science? It's actually the coordination device of science that is broken. It's the system by which we evaluate scientific productivity, right? So we all know that today scientists have to produce papers, right? It's all about producing papers, more papers. That's how we get evaluated. That's how scientists get tenure. That's how scientists get grants. That's essentially the inputs to the incentive layer of science. And specifically, a paper, I published a paper in, behind that, there's what's called a version of record, called the VOR. The VOR is essentially an act of speech by scientific publishers who erect that object as the finalized, peer-reviewed academic manuscript. All of the system of science coordinates around the productions of these VORs. It's an incredibly consolidated system that coordinates multiple agents. It's very slow to change. It's very difficult to change. So it coordinates researchers, coordinates funding agency, coordinates tenure committees, coordinates policymakers. It's a multi-agent coordination system. At the very heart of that, there's these VOR producers. We call them publishers. So what do publishers do? Well, they carry out the peer review. They have editors that verify the suitability of a certain piece of science. Everything is centered and focused around the production of these PDFs or XML objects, essentially. Everything beyond that is considered second-class citizens. So code, data, all of the things that make science reproducible and verifiable are incredibly undervalued in the current system. That system, that coordination device, you could think about it as a three-layered system. At the outside, you have what's called a protocol, right? DeSci has a protocol, little known fact. You have a DOI, which is a key to your paper, a unique identifier. You have metadata that's registered with Crossref and other registration agencies. You have a certain format, which is JASP XML, that encodes scientific papers. And you have what's called the journal impact factor, which is something that is bestowed by what I like to call the oracles of the VOR. Essentially, think of a database that is curated. It's called today the Web of Science. And that database essentially attests to the production lines of these versions of record. So they say, well, this publisher that has this journal, they're producing legitimate science. And therefore, the citations that are contained within this object of technology, this paper, will count for the incentive layer. It will count for your hiring decisions. They'll count for your tenure committees. They'll count for grant applications. Now that system is running into a brick wall. First of all, it's suffering from incredible consolidation. Back in 2000, 47% of the market was controlled by the top 10 publishers. 23 years down the line, in 2023, 73% of the market is controlled by the top 10 publishers. That system suffers from security breaches. I don't know if you've heard about the problems around paper mills, around the fact that you can buy citations online, around the fact that you can buy authorship. And by the way, the price of authorship is going down really, really quickly. It's now about half the price. It's now about half the price of your typical APCs. What's an APCs? Well, guess what? Scientists, when they want to publish a paper and not have that paper behind a paywall, they have to pay the publisher. And those fees range typically between $1,500 to $10,000 on the high end. And buying authorship in a way that counts for you because it's been indexed by the oracles of the VOR, right? The Web of Science and Scopus, typically about $1,000, right? So that system right now is in a very dire situation. You could think about it as a paper industrial complex.
And with the rise of AI and LLMs, the cost of breaking through the multi-layered defense system of this war coordination device is just going down by the day. Clearly, we need to think about another future for science. So how do we think about it? How can we escape the incredible pull, the attractor state that this system creates? It's very sticky and it's incredibly difficult to reach the escape velocity necessary to provide an alternative. So how can we escape it? Well, we have to unlock what I like to call meta-science space travel. So what's that? So essentially think of science, think of the coordination system of science as one possibility among a zillion other modes that the system can coordinate over. For example, unpaid peer review is a choice. It's a choice of the system. Things like we don't value research data, it's also a choice. All of these things are choices that have coalesced into a current coordination system, but it is just one way of doing things. So by unlocking meta-science space travel, what do I mean by that? That means we expand the space of possible coordination that we provide to scientific communities. Over what dimensions? Well, the first one is over the unit of knowledge. So rather than just saying, well, scientists produce papers, we should think about that as scientists producing research objects, right? Research objects are essentially rich containers that can contain research code, that can contain data, that can contain any types of arbitrary artifacts that are encapsulated into this object, into a dynamic, versionable object that can be incremented over time. The only way that we have to fight authorship for sale is incremental publishing with verifiable provenance. The second dimension we have to think about is, what do we certify? Today, we have this idol that we've erected. It's called peer review. You've all heard of peer review. Peer review is essentially a process by which scientists opine on the soundness of the results, on whether the conclusions are warranted given the data, given the analysis, and all of these things. What happens, though, is that peer review is a black box. We don't really know. There's a lot of different policies and how journals carry on peer review. There's a vast variations about what is peer review, but none of this is made explicit. So we need to break that down. We need to unbundle the certification function of peer review into its component part, and we need to expand its scope to encompass things like, well, proof of open data, proof that this research object is actually internally reproducible, that you can get to the results back by the objects that are contained within, or things like the commercialization potential of a piece of research. So we can extend the scope of certification and break down the peer review system that provides additional coordination space to scientific communities to think about what they value and what they want to certify. Another thing that's an artifact of the old days where we had prints, why is it that it's one article, one journal? That's a very strong norm in the VOR protocol. There's a norm, there's a taboo. You cannot send a paper to two different journals. That is not possible. That is considered heresy. They will go as far as contact your university to say you've done it. There's no reason for this anymore today. You could think of a system where pluralistic curation is a thing, where you can have multiple scientific communities certify a given research object and provide pluralistic perspectives on the value that it provides as its knowledge contributions. And finally, a third dimension that we need to unlock meta-science space travel is we need to expand the scope of community sovereignty. So it used to be that communities in science were everything. Journals are essentially newsletters for specialist community. What are the things that is worth paying attention to within my very specific niche field? That's the function of a journal. It's a system to capture attention. Now, today, a lot of that has eroded away. We now have alienating production lines in mega journals. We do peer review, we certify work, we run editorial processing just to get brownie points on our CVs and to essentially let funders, university, all of these agents that are coordinated increase their rankings and essentially compete against each other. So it has moved from a mechanism by which communities were central and provided a newsletter, an attention stream, an object you should pay attention to, into something which has turned into an alienating production line. And the question, of course, is that, okay, well, are publishers evil? Good question. Many people would say, yes, they're evil. But actually, I'd say, no, they're just profit maxis. And it turns out that if you look at the strategy space, like what would you need to do in order to maximize your revenue as a publisher? Well, it turns out there's a couple of overpowered strategies that still haven't been fixed. And these overpowered strategies are things like consolidate vertically and horizontally. Big publishers are profitable. Small publishers and scientific societies struggle for sustainability. There's a record number of RFPs from societies and small journals looking for publishers to take them on. They're just throwing the towel. They don't have the negotiation power to have sufficient revenue to perpetuate their operations. So they're disappearing. And it's an inevitability that the system continues to consolidate as shocks hit it. And what do we need to do about that? Well, we have to think of ways we can make the strategies that are good for science, good for your bottom line. Things like increasing the scope of the unit of knowledge. Things like increasing the scope and unbundling certification, and actually making it the optimal strategy to provide the best possible service for scientific validation. If that was aligned with the goal of maximizing revenue, science would be wonderful. It's not. And thirdly, expanding the scope of communities and giving them sovereignty. What if we, it is not a fatality that peer review is unpaid. It's a design choice. You could have, systems in which, in my society, we reward peer reviewers, right? We pay them piecemeal for the work that they provided. Other societies might have other ways that they want to channel the value that they create. They might, provide an initial income to PhD students. They might have all sorts of other mechanisms that they could enact. But you'd have to be a fool as a publishing executive to provide these options on the table. You'd be going against your fiduciary duties. All of this stuff costs money and is bad for your bottom line. All of the things that are overpowered, consolidation, volume, data capture, all of those things are good for your bottom line. So one of the missions of DeSci, one of the core missions, is to fix the broken metagame of science. And how can we do that? One of the things that is incredibly promising is this concept of open state data networks, right? So rather than having competition over data, because I have my database, I have my platform, I keep my users captured within that, how about we had a shared database, a multi-client database? It's permissionless that allows you to have provenance over these objects so that you can have multiple entities operating within that system. And that's one of the teams we'll be exploring at the conference, SciOS, that we're going to be hosting this week. So please come and join that conference. We'd love to have you. And so essentially, think of DeSci as the unexplored meta-scientific coordination space and all of the possibilities by which that system could re-coordinate to align the incentives of its agents towards producing better, more durable research, more verifiable science. So this is what we do at DeSci Labs. And it's not just us, it's the entirety of the DeSci space, just to be absolutely clear on that. And so today, we want to show you what we've been building. We want to show you the latest version of our application, which is being co-developed with a protocol called Codex, which stands for Collaborative Open Data Exchange. We want to also provide you with opportunities to hack on interesting things. So we've built out APIs and we've built out ways to programmatically interact with this application so that you essentially commit data to that network and have it surfaced in this app, which is just one instance of a deployable app that anyone can deploy. Everything we do is open source, and you can customize this. Now think of a future in which you have an open state data network and you have multiple application layers on top of it that all interact with a shared data lake. What does that lead to? That leads to a world where you compete over features and not over data. It has tremendous benefits for the end users if these visions can be realized. So there's going to be a prize for this hackathon. We'll be judging the results at the end of the week. We will be providing the winner with 1,000 USDC, second position with 700 USDC, third position with 300 USDC. So we're very much looking forward to your submissions. And we will be here to provide guidance and to provide information about how you can use the tools that we've built out that we're going to be showing you today. And with this said, I would like to pass the speaker to Andre, who's our design technologist working on product at DeSci Labs. And after we'll have Edward, who's protocol architect at DeSci Labs. So thank you very much.
Cool. Thank you, Chris, for that excellent introduction. I'm going to preview DeSci Nodes v2, which is the first user-facing application to the Codex protocol. This is an extremely product-focused talk, and in the interest of previewing what the Codex protocol is about, there are just three entities which you need to understand. The first is the DPID. This is a persistent identifier which is issued to an author when they publish their research. What the identifier does is it points to a tree of files, unlike the DOI, which points to a single file. And this identifier persistently maps to every file that it points to. So if you ask for something like a document or a piece of code or a piece of data, you are almost guaranteed that it exists and that it'll resolve. So you won't face messages like missing file or error not found, or be asked to pay a fee to view it. Another property of the DPID is versionability, which you can think of as making a copy of this tree of files and then modifying it. So you can begin by publishing your work as a set of documents or a set of code and data files, for example, and then incrementally add outputs like a manuscript or results notebook or even a blog post. The insight is that because it shares a persistent and common identifier, citations and impact can aggregate over time. So what this means is that you could have published version 1 first, and it would have started to gain citations, and then published version 2, and that would have tracked citations as well. And you would have accumulated all of these citations before even publishing your manuscript. And what this allows you to do, and what we're calling, and Chris mentioned this in his introduction, but we're calling the stream of publication outputs the research object. And that's the second entity of the protocol, which you need to keep in mind. What it allows you to do is reimagine a publication from an outcome of the research process captured within a PDF to an unfolding narrative of the process itself, where artifacts are incrementally published as soon as the authors see fit. The last piece of the protocol, and this addresses the question of how to distinguish between what's trustworthy and what's just not scientific, is the attestation, which is just a verifiable claim that points to any part of the research object. Claims can be broad and recreate things we see in science today, like peer-reviewed by a certain journal, but also atomic and granular, breaking up into units like if data is available, or code's available, or the results are reproducible, or even subjective claims, like if the results are like the results being big if they're true. Now, if I make a list of all the properties of the Codex protocol that are intrinsically good for science, so things like being resilient against link rot, preventing vendor lock-in, no content drift, and also bring in things that I haven't mentioned, like it being machine readable, every artifact being machine readable by default, or FAIR enabled by default. The problem is if you take it to a scientist and you give them all of these things, they'll just be like, okay, but can it help me get tenure? The problem that the application is to solve is not just to teach and convince people that the protocol is important, but make doing so easy, engaging, and desirable. So if you pay attention to the way the publication systems work right now in the journal model, you essentially go through pages and pages of forms, and these forms, it's painful to fill, there's no autosave, the UX is just horrible. On nodes, publishing is going to be extremely easy. This simultaneously also means getting rid of the UX frictions of Web3. Most scientists won't have wallets. Interacting and publishing with wallets and signatures will feel foreign and maybe even alienating. And all of this will be abstracted away. And to the engaging and desirable piece, it needs to recognize that we still need to build bridges to the existing system and lay clear tracks for earning reputation and credibility. Okay. Before I transition into the demo, just to set the scene, this research project is something that I wrote a couple of years ago. It's a study on modeling rainfalls. It's on modeling rainfalls with a technique called cellular automata. And I'm going to take you through how I would have used nodes had it existed to publish this project. So yeah, the project is titled A Weighted Cellular Automata for Flood Modeling. It uses a technique called cellular automata. In short, you take terrain, you divide it up into a grid of cells, you pour water over the cells, and specify instructions of how the water can flow. It's nothing revolutionary. If anything, my only contribution is just speeding up an existing simulation technique. But it did lead to some like really cool plots like this. Or even this. I love this. This is like a dam being erected and water flowing through it. And I published these plots, these figures, alongside a notebook, a Jupyter notebook with cached outputs of the simulations themselves, simulation code with passable object-oriented programming on display, and some plotting utilities. And when I published this in version 2, I didn't have to, there weren't stipulations on what the correct file format should be, how big those files should be, or the specific presentation of the outputs. I just had to come and upload my files, and the system took care of the rest. Every node gets 100 gigabytes of storage for free, but even that's somewhat of an arbitrary limit. There's a node right now which has 27 terabytes of data stored on a content address network that anybody can access and reuse and reproduce. Once files are uploaded, there's a viewer that supports most common file types on the right, and a drive that you can just quickly go through and view all of these things on the right. And if you go to any one of these files, let me just say this one, and you hit this info icon on the top, you'll have ways to download it immediately, shortcuts to site, of course, but also importing it into your programming environment of choice with something we call DPID fetch. So just by copying and pasting this and running this code, this will be instantly available for you to reuse in your own work. With metadata fields as well, there wasn't a stipulation or a mandatory requirement to have these filled. And right now, and I think Flavie mentioned this earlier, we have an automated metadata extraction pipeline that does this for you, and you'll just have to approve it. Now, when I published this version, remember that there wasn't a manuscript ready, but there was code and data that was ready to be validated. And what I did was I just went to the attestations tab up here, and browsing a list of suggested attestations, I selected open code and open data. Open code is an attestation issued by DeSci Labs that certifies that code is available in this research artifact in a format that is timestamped, immutable, and permanent, which the system guarantees, and also has an open license, and also has sufficient explanation so that people could reuse it if they wanted to recreate the results. Now, when I claimed this attestation, what I did is I left a comment. This is me, lowercase Andre. For the purpose of this demo, I actually had to make 2 Andre accounts. So that's lowercase Andre. There's Andre Vacha, the reviewer. So I just said there are 2 files relevant to this attestation, ca.py and plottingutils.py, and I've added descriptions to both of these support reuse. To which Andre Vacha, the reviewer, who's a member of the DeSci Labs community, also me, was able to come in and certify this attestation. If you think for a second about what this is doing, is an attestation opens a communication channel between a research object and the community with members. And community members can come in and verify this claim on a research object. Uppercase Andre Vacha said, "This looks good, Andre, but notice the sequence of -100s that show up in your elevation maps. Surely this elevation, especially when nearby terrain is near sea level, is unlikely. Maybe this is a convention used to mark sea levels of our oceans." Reviewing this comment, I realized that uppercase Andre was right, and I added him to my contributors table in version 2.
Double credit, well done.
And so now, zooming a few weeks into the future, I'm going to switch to version 3, to which I've added my nicely typeset manuscript, which will load in a second. It looks and smells like science. And all I need to do again was just upload it, and then let me just show you how to do that. I pin it, I assign a type, just to guide the reader to it, and then that's it. And then I hit publish, which I can take you through in a second. Publishing is handled with Orchid, which I can demo. After which I just confirm the licenses for components that didn't have the licenses applied, and then I hit publish, and that's it. The UI is non-blocking. In the meantime, what I could do is go back to my attestations view, and I'm going to drop down the suggested attestations. And what it lists currently are the set of communities who are using DeSci nodes to test out the attestations primitive. They're Gridcoin, Longivus, the DeSci Foundation, and Moondao. Now, communities fundamentally are just people who share a purpose, and they express that purpose and sort of act on it by creating attestations. So Gridcoin, for example, created the reproducibility enabled attestation, which is about tying your manuscript with the code and data needed to reproduce it, and also the used BOINC and used folding at home attestations. I haven't used either of those. So I'm going to look at the next one. The Longivus, which is a journal that curates research associated with longevity. It's a scientific manuscript attestation, which is shared with the DeSci Foundation, longevity research, and commercializable. Of these, the ones that I'm really interested in are scientific manuscript and the DeSci Fund for Scientific Innovation. Now, when I claim the set of attestations that a community requires, what happens is that if I go to their community page, my work appears on, sorry, let me slow down and show you this again. My work appears on a tab in the community called Radar, and this surfaces all work which claim the attestations which they've listed as entry requirements. So communities shape the attestations, reflecting their own standards and their own purposes, which they then set as entry requirements to their community. And then when any node claims these attestations, they appear here. This doesn't mean that the work itself is valid or that it meets the standards of these attestations, but they appear here. So I'm going to switch to uppercase Andre mode again. And I'm going to imagine that, let me just make sure I submit this. Yeah, this is, just make sure. Yeah, so this is the uppercase Andre view, and imagine that he's a member of the DeSci Foundation. He'll have access now to verifying if a scientific manuscript is present. Ideally, lowercase Andre would have left some marks about where this could be. It looks like this is a manuscript. Okay, so I'm gonna just verify it. And also, this is an incredibly self-congratulatory exercise. I don't meet the requirements of any of these. But in the interest of the demo, I'm gonna hit verify for the DeSci Fund for Scientific Innovation Eligibility, which has a $3,000 prize, I think.
Triple
So
credit.
I'm just gonna toss my hat. And if I go back to the community view, what happens is that my paper appears in a second tab in the community page called Curated Nodes. And these are all nodes that have validated the attributes by community members and represents the sort of sum total of contributions that were made. So this is it. That's the research object which I submitted. I call this a preview because the attestations that I just showed you were open attestations. The bar for verifying them is incredibly low. You just need to be, if you're in a community that shares the standard, you can just come in and verify it. But what we hope to do with attestations is treat them as playgrounds for meta-scientific design. So you can have closed attestations in which members above a certain reputation can only verify it. You can have attestations which, for example, anonymize reviewers and make their comments only viewable to the author, recreating something like blinded peer review. Or you could have attestations which reward their reviewers at the end of the validation process. Yeah, this ends the overview of the DeSci Nodes product. It's where we are right now. We're working closely with communities to shape both the attestations primitive and the community primitive. So if anyone here is interested in joining that, let me know as well.
You can talk to me as well.
And talk to
about this,
Ellie.
and I will send you all the information.
Yeah.
If you're a community interested in curating nodes on DeSci.
Yeah,
I had
that's it.
a question as far as the TradSci life cycle goes. At what point does the scientist work to bring these ideas and research into a product or a device for the real world, or is there no incentivization structure to do so? and they just go back to thinking and writing. And
So there can be.
recycle.
So there's a tech transfer office in universities. So if you make a discovery that you think has value when it comes to the real world, so typically there's the tech transfer office, they might file the patent for you. In exchange, they'll take, maybe 10% of your company or whatever the kind of terms, which is typically very flexible and bespoke. But in general, translational research is a problem, right? So there's a big innovation gap. I'm sure you've heard about it. There's very practical applications and very fundamental applications. But in the middle, it's a little bit of a no man's land, right? This is where risk is maximum, right? Where the outcomes are most uncertain and where the incentives are lacking, right? So this is like called the innovation gap. It's what's in the middle here. I think there's other groups, working on this, like Molecule with IPNFTs, that are, hoping to really be able to reduce, the steep loss of incentives that happen around that innovation gap, right? And I think this goes again to this whole idea of, pluralistic incentive layers, right? Where we have to think about not only new models for attestations that could help bridge the innovation gap, like having attestation that's well, this has commercializability potential. That's a very valuable attestation that is not carried on, by traditional peer review or scientific journals at all. But that have in principle a lot of value for the industry. Similarly, the openness of data, the reproducibility of results can have a lot of value for industry because the people in the middle, like doing deep tech, they very much value not spending millions of dollars to have results that don't replicate from fundamental research, right? So for them, they have an incentive to ensuring that reproducibility of, let's say, cutting edge bio research is somehow something that they can trust, right? So the idea here, again, this is why I talk, amusingly perhaps about, traveling meta-science space, right? It's about creating these types of primitives that allow us to reshape the incentive landscape in the coordination devices of science.
Yeah, absolutely. And do you have open APIs for other platforms that want to ping or use ZKP to verify author identity or publish papers,
so,
things like that?
So what you've seen, first of all, you've seen the ORCID integration here. So it actually creates a DID in the background so that the user doesn't need to know about it. And that DID is then assigned to the user's ORCID profile as supplementary keys and identifiers, right? So and then we can even write the proof that they own this particular DID on their ORCID record. Right? And so the idea here is that we're using a very much TradSci identity layer, but we provide the researchers with a very frictionless experience in logging in because it's the tool they use. And we do create a whole Web3 thing underneath in a very subtle and discrete way. And we write that back to their ORCID records, right? So that's one way. There was another part to your question.
For example, a kind of third-party platform like retrieve a yes or no through ZKP.
Yes. So for example,
Verify.
we're working with bioRxiv right now. bioRxiv is very interested in aggregating signals of trust, right? So the big, we're very much aligned with the whole preprint platform and the movement that is essentially published and filtered. The opposite, which is ridiculous, which is filtered and published, right? And the archive family of platforms have been pushing that model for a very long time. But the problem that they have is they don't know how to aggregate back signals of trust, right? And so what we provide are we'll actually be providing ways for bioRxiv to pull all the attestations that are on the OpenState data network back to the bioRxiv interface, right? So that you essentially, and this is one of the properties that is very interesting with OpenState data networks, is that in principle, every platform out there can go on this data network and fetch the identifier, the DPID, and then run a query that says from this DPID, return all the attestations, right? And then from these attestations that they've returned, UI hook, put it in the UI, right? So that's a little bit, one of the core thesis that we have is this idea of creating a vast interoperable data network that is permissionless when it comes to retrieving these indicators, right?
Excellent.
And as far as integration goes, so this is the user-facing, more like experience for publishing and consuming research as a human being. I have written an integration library as well for integrating with our backend systems, for programmatically creating nodes, uploading files tagging metadata, and like basically doing everything you can do in the AI. UI.
Same thing.
But programmatically. So this is kind of going to be the topic which we hope people are going to be hacking on. In particular, something that would be really interesting is ingesting like externally hosted research publications and creating notes programmatically. So let's say you take the Google Scholar profile of a researcher, you can iterate through the publications, just upload the PDFs to new notes and basically get the starting points. And something worth pointing out as well is that just because you upload something into notes doesn't necessarily mean that it's publicly available automatically.
Yeah.
We do provide like a staging area for you to like privately iterate until a point you realize like, okay, this is like a checkpoint, in which case you can publish it. It will be anchored on chain, and all of the CIDs will be publicly resolvable. And then you can keep on iterative working on the next version until the next publish. And you can do all of this programmatically. So it'd be really cool to see what people can come up with as far as integrations go.
My question is, my question is with regards to the hack prizes. So you just mentioned one, some of the challenges maybe, like do we have any sort of concrete information of people who are maybe going to hack? So where should we look? And maybe just now some loud suggestions.
Yeah, so we've got a couple of out loud suggestions. You were mentioning one. Eric has one that he wants to share as well. And then we also, in that documentation that I gave you, if you could send that out to everyone, we have like a list of like 6 or 7 of these that are interesting. And Eric, you can talk about maybe stuff.
Sure, absolutely, happy to. Amazing presentation, Joe. So yeah, one of the things that I did a good job of pointing out is that ultimately this Codex protocol, this DPID protocol, is aimed at making the lives of researchers easier. And there's a lot of incredible stuff that we could do, but there are also a couple of very low-hanging fruits that are well suited to a hackathon. So for those of you who are familiar with research, one of the biggest bureaucratic constraints that a researcher has on a daily basis is the process of filling out forms. There are so many forms. There are unending forms on interfaces that look like they're from the 1990s. One of the very interesting things that we can do with the Codex protocol is make it really easy for these forms to be modular, to compose on top of each other in a way that ultimately then ends up as a well-structured, I guess I wouldn't call it a database, but a well-structured format for information that can later be used in conjunction with metadata of all types to help automate the process of filling out these forms. And this is, I think, intended to be a self-contained project that can be accomplished in the space of a week and can have a real and meaningful impact in the lives of everyday researchers. So that's one of the things that I think I was kind of thinking about. More than happy to talk to other folks around how that can be done, and I think Edward may want to be involved in those conversations as well, but just as a thought.
Yeah, I had a lot of ideas for hacking projects, but as soon as I wrote them down, I forget them. But they are in the docs.
So I just shared the docs in the Nerd Labs chat, if everyone wants to look there. If you're not in the Nerd Labs chat and you want to speak to me or any of these guys.
Yes, ultimately to be eligible, have a GitHub repo, tag DeSci Foundation or DeSci Labs, and essentially, if your project's cool and the hack's successful, we are more than happy to turn it into something real that people will actually use. So the efforts you will put in this week, we hope will be not for nothing, right? Our goal is to be able to have a vast ecosystem of interoperable services that add value, right? That create a system where everything is more than the sum of its part at the end of the day, right? So you could think of what Eric said, right, about the form filling system, right? Or enriching metadata, that's one. Other thing that could be valuable is, let's say, well, go on PLOS website where everything is open access and data and license restrictions are very open. And can you write a script that goes on PLOS website, finds the XML and the PDF, looks for links to data, looks for links to code, and essentially structures all of that information in some nicely structured JSON that can be then fed into the Nodes API such that
you can automatically batch filling the Codex protocol with data that has the licensing requirements that are sufficiently permissible that they can be rehosted on an alternative system, right? That's an example. There's many types. Another thing that would be incredibly cool is, let's say, look, we have an ORCID login solution. How about, if we could have a system where a researcher logs in and then he has a choice, he can give permission to upload all of the papers that they have on their ORCID profiles on the DeSci node platform, right? Think about the power of that. You just have a single login of a researcher, like, hey, do you want to mirror your work on this open state data network that's good for science? And they click yes, check box. And that would automatically push all of their work, all of the corpuses. You need to, of course, write the system that would go and fetch these articles out. It's non-trivial, but that would create also a lot of value potentially. So there's a whole series of really neat tools that you can build out to interact programmatically with the Codex protocol and the nodes interface. You'll also have direct feedback. So this is another cool thing. You'll be able to have a tab where you have the nodes platform open. You logged in. You'll be able to get your API key from your profile page, and you will be able to see the drafts of the objects. So you'll have direct feedback. It's not going to be a black box with obscure error messages. So you'll be able to see the objects that are created. But essentially you'll be able to have direct visual feedback of what you've built out. So that should be really helping you getting familiar with these tools that we're making available. And again, so these hackathon ideas that you'll find in the documents, these are things we came up with that we think are valuable. But if you have these really cool creative ideas, it is by no means the only things you can hack on. We're very much open to any kind of really cool application. If you want to run an LLM integration over DeSci nodes, just do it. There's a lot of really cool things you can do, and we'd love to be able to support you in that. And also, we will be crediting you in the repos that you've created, and we will be showcasing you as part of our community showcases. And so our goal is really to be able to provide back credit and recognition to all the people that contribute to this project, because ultimately everything we do is open source. And our goal is to, and I think there's really a great potential here to trigger an open source movement about building scientific publishing 2.0.
Maybe I can just add a few words about the DeSci Fund for Scientific Innovation. So Andre was already pointing out to it quickly. So the DeSci Fund for Scientific Innovation already enables you to earn money with your research if you publish it on DeSci nodes. And the way it works is you basically upload your manuscript and any other artifact that you want. Then there's a creative phase where you can come up with sort of a visual representation of the meaning or the essence of your research project. Can be a JPEG or GIF or whatever. And then you can submit that to Artisan Fund, where the fund is actually being hosted. And if Artisan actually selects your contribution, they will create an open NFT collection that will be offered for sale on their platform. The sales receipts will go to you as the author, and they will be matched with funding that has been provided by the DeSci Foundation and by Artisan. And so if you're creative, this is a way how you can keep complete control over the copyrights of everything that you've done, and yet you can publicize your work, you can basically tell the world, show the world why it's relevant, and earn money with it. So that's up on live.
That's great.
Cool. Well, thank you guys.
Come get some socks.
There are also stickers down there. Right, guys, talks are done. Thank you so much again, DeSci Labs. Please feel free to chat with them. There's also a massive barbecue going on. One thing, smart people in this room, we have not got a very good lighting situation for the grill outside, as in lighting. So if someone thinks of something smart about how to light the barbecue area, please feel free to do that. Okay, thank you.
I have some creative ways to fire.
Trust me, it's not enough. It's not enough.
Fire. We saw this one eons ago.